name's Rachel Doree, and I'm with group 36, and we're going to do problem 1120 out of the book. And here we're given this structure, and it's made up of 3 parts with 2 fixed ends. We have an 8-kip force pushing over here on joint B, and we're asked to find the internal moment and the moments at the fixed end. Here we have the deflected shape, and you can see from the delta B and delta C that we can assume that they're equal, and we're just going to call them delta to simplify notation later on in the problem. Here, we've broken it down into the 3 separate beams from the frame, and we've applied equilibrium equations to the frame ends of the individual joints. And we get these 3 equations, 7, 8, and 9, and later when we work through the matrices and we get values, we'll plug them back in here to get our final answer. And now I'm going to turn it over to Rashad.
Thank you so much, Rachel. So here we have the general slope and deflection matrix. And as we can see, the frame has 3 beams. So we apply this matrix to the 3 beams AB, BC, and CD. In this beam AB, delta A and theta A are both 0, as A is a fixed end. And the same happens with the ND in CD, as the ND is fixed. So now, Hero, do you want to come? Continue.
Thank you, Rashad. Okay, so Rashad just explained to you how we set up our slope deflection equations in matrix form. From these equations, we can solve for our 6 moments that we're looking for and from our original structure. And using those 3 equilibrium equations, we can substitute our moments into to find these 3 equations with 3 unknowns, which are our theta B, theta C, and our delta, which we assumed equal for both sides. Now, for solving from these 3 equations, you get either EI, which is our constant value, times your delta B, delta C, and your theta B, theta C, and delta. And from these 3 values, you can plug into our matrices to find the 3 values we're looking for are MAB, MBA, MBC, MCB, MCD, and MDC, which we can see the final results here after we've plugged in our unknowns. And from these unknowns, we can go back to our original structure and plug in to find a moment diagram. Here, I'll just do that quickly for you. So here we have a moment of 15 kips at here, and then this is 19.5. So our moment for this beam is going to look something like this. And then from here, we have the same equation, the same moment on from both beams. So it's also 15 kip feet, and 20.1 over here. So that is our moment diagram for BC. Now, to find the final one, it's going to be our moment at CD, which was 20.1 as well. So it's going to look like this. And our final moment was our largest moment, 36.9. So this will be our final moment diagram. And that should solve the problem. Thank you.